Today I'm going to perform a demo showing the re-crystallization method. Okay, and what we need to test 4 solvents, which are acetone, petrometer, 95% ethanol, and water. So you need to select 2 solvents and to discard 2 solvents. Okay. So first thing you do, you have 4 test tubes here. Okay.
That's acetone.
Acetone, yeah.
Acetone. That's the petroleum.
Petrometer.
One second. Petroleum ether. And that's the ethanol.
Yeah.
And that is the water, H2O.
Yeah. So H2.
What is this stuff? This is benzoic.
Benzoic acid. Yeah.
Benzoic
Acid.
acid, and that is what you have there, yeah.
This benzoic acid, yeah. Because you have big crystals, so I need to grind them. So what you do?
Okay. Yeah.
You add a small amount of benzoic acid to each test tube.
Look at them each. So we have the acetone one, petroleum ether one, ethanol one, and the water one. Okay.
So now we are going to test the solvent. I will start with acetone. What I do, I use a plurange.
Let's see what that is. What's the plurange?
Yeah, that's a plurange here.
So it's a syringe with a plastic and then a
Pasteur pipette.
Pasteur pipette. So
I'm going to add.
how much are you adding?
1 milliliter. Add 1 milliliter of acetone, and I shake and see what happens.
What happened?
As you can see, benzoic acid, so it's completely soluble at room temperature. So acetone is not a good solvent because acetone does completely dissolve benzoic acid at room temperature. Now we move with the second one.
What's the solvent?
The solvent is petrometer,
Petroleum ether.
which is a very volatile solvent. We get another plurange. Okay. So add 1 milliliter. And as you can see here, it is not completely soluble. That means that it is not completely soluble at room temperature. That means that we can select petrometer as solvent. And then the third one is ethanol. You are going to use blue range. Add 1 milliliter.
Let me add something real quick. So when you're doing the pluringe, you go into the syringe to the 1 mil mark, but the solvent's actually down below. It's so it's not like you're filling up the syringe with the solvent. You're just using the syringe as a vacuum, and the vacuum sucks it up into the pipette. So inside the pipette is 1 milliliter, and you see it right there is 1 milliliter.
Yeah.
So yeah,
It's good, huh?
yeah, it's good.
And shake the test tube, and you see that 95% ethanol does completely dissolve pure benzoic acid at room temperature. That means that it is a bad solvent.
Cool.
And now, the last one will be water. I use deionized water, D-water. I'll do the same.
Adding 1 milliliter also.
Yeah, this time, like that. And as you see, water does not completely dissolve pure benzoic acid at room temperature. So now, see, you had to select 2 solvents and to discard 2 solvents. Okay? You need to select petrometer and water because they do not completely dissolve pure benzoic acid at room temperature. You need to discard acetone and 95% ethanol because they completely dissolve benzoic acid at room temperature.
So they're unlikely because they're completely dissolved. They won't like if you cool them down or something, crystallize out. So therefore you need to throw them away because they're just bad. They're too good. They're too good of solvents. So for crystallization, they're bad solvents.
Yeah.
Okay, got it.
So now we did select 2 solvents, but the solvent I'm going to use to recrystallize benzoic acid will be water. I'm not going to use petrometer because petrometer is very volatile, okay, and it's hazardous.
Flammable?
Flammable.
Yeah.
Okay, I'm not going to use petrometer as solvent. I'm going to use water. So the first thing we do, we need first we're going to use a balance. We need to put that to 0.
Power. So there's the
You need to put that to 0, yeah.
Tear button. Let's see. There we go. I think it's 0.
0, yeah.
0 now, yeah?
0, no. So I'm going to add a certain amount of impure benzoic acid.
So it's impure with some impurity.
Impure benzoic acid. Okay, which means 380 milligram of impure benzoic acid or 0.38 gram of impure benzoic acid.
Okay, so 0.38 grams, which is 380 milligrams.
Milligrams, yeah. So what you need to know here is that the amount of pure benzoic acid you are going to get after vaporization has to be less than the amount of crude product, because this one is a crude product. Crude product means that you have your product and some impurities. Okay.
So you're hoping they maybe get 200 milligrams or 100 milligrams or something less, because if you have more, that would be a problem.
Yeah. So now we are going to use an Erlenmeyer flask.
Erlenmeyer flask?
Erlenmeyer flask. We are going to add impure benzoic acid to the Erlenmeyer flask. Then we are going to add some water.
How much water?
So
how much did you add?
I will tell you.
Okay.
And I add 10 milliliters of water. Okay, 10 milliliters of water.
10 milliliters. You use the graduated cylinder, basically 10 milliliters.
Yeah. So now, water has a high boiling point. Okay. So I start to hit the sand bath. Here.
So you started this is a sand bath. It heats sand. And you started it earlier, so
earlier
you
because
heat it up a bit, and now you put your Erlenmeyer on the hot sand bath.
Yeah.
Okay.
And you use a glass rod and you start to stir. And as you can see here, it's sparkling soluble at room temperature.
It's insoluble. So you're heating it up.
Yeah.
And the boiling point of water should be 100 degrees Celsius.
You need to be patient when you recrystallize. You have to wait.
So you're trying to get it to everything to dissolve at high temperature.
Yeah. Exactly.
It looks like a little bit dissolved. Yeah.
It's
getting there.
all gone, yeah. You have to be patient. It's just so good that we hear your voice. And actually we are not
hot's that sand? Let's see. It's pretty hot. Yeah.
It's just as water has a...
Yeah. I guess about 80 degrees Celsius.
Yeah. It's almost done.
Do you want it to be completely dissolved, or or okay? So as much as you can get, yeah.
It's clear that sometimes you may have some impurities which are not going to be soluble at all, and in this case we do what is called a decantation.
Yeah. So it could be a mixture of multiple compounds.
Yeah.
And if you could, if maybe your impurity is insoluble, and then you can kind of pour out the good stuff and leave behind the bad stuff.
Yeah.
Yeah, got it. That's probably what's going to happen here. It's mostly dissolved.
Yeah,
I mean, there's a little bit of junk in there.
Just 1 minute more. Okay, as you can see, it's all dissolved.
Mostly. We'll say there's a little bit of stuff, but that could be bad stuff.
Yeah. So when you have some of that, you just do what is called a decantation. I'm going to decant.
So you're pouring.
Yeah.
So you decanted it. Yeah. You decanted it, which basically means you poured it while it's hot from one flask to the other.
Correct.
And that leaves behind a little bit of junk, probably junk.
Yeah, that's junk, yeah.
And then the good stuff is in the second one, yeah?
Yeah.
Okay.
Just wait.
Go.
So now, as you can see, so you have your pure benzoic acid crystals.
In water.
In the water.
Yeah. That's good.
Now, once that is done, first turn off the regulator, you unplug.
So this was, the sand bath was plugged into this little guy.
Regulator, yeah.
Into the regulator.
Yeah.
And it was on full blast or no?
Yeah.
It was on full. What was the setting before?
5.
5. It was on about 5, which gave you about 100 degrees. Okay, so you unplug the sand bath from the little regulator.
Now we still have 2 steps to go, but I need to check first the vacuum. The vacuum is working. I need a hose. I need a filtration flask.
It's a filtration flask?
Yeah, filtration flask.
You're going to do a vacuum filtration, yeah?
Yeah.
Okay.
You need a neoprene adapter, which is that?
Neoprene adapter.
And you need a Büchner funnel.
Buchner or Buchner?
Büchner.
Buchner.
Büchner funnel.
Okay, it's a ceramic funnel.
Yeah.
And cool.
Yeah. And what you also need to do, you need a clamp. You need to clamp the filtration flask. That's to avoid technical mistakes.
So you're going to clamp it so it doesn't fall over.
Yeah.
You got your neoprene adapter. You got your vacuum hose.
Yeah.
Very nice.
And you know what you need here was filter paper.
Cool.
Which I have here.
So you got the paper inside the funnel.
Yeah.
And you got the hose.
Yeah.
And you got the vacuum line.
Yeah.
And you're ready to do your vacuum filtration.
Yeah. Now I open the vacuum.
Okay, the vacuum's open. And we hear it.
Yeah. And that. you still see that you still have some pure benzoic acid inside the LMR flask. So to get most of them out, just need to add some water. Okay. And you wait 1 minute.
You're waiting so it dries it, yeah?
Yeah.
So all the water gets sucked through?
Yeah.
I think, just as a thinking out loud, I think if you would have decanted it and then had this already ready to go, and then immediately poured it, actually, no, you don't want to do that because it might be still hot. I don't know. I think you get a little more yield.
Yeah, but in OChem2 lab,
Yeah.
the experiment we are doing,
Yeah.
the molecule we have there, so
Yep.
we need to do that. For
Okay.
OChem1, that's still alright.
Yeah, that's fine. Your yield looks good.
So what is my spatula?
So there's the pure benzoic acid, purified benzoic acid.
Yeah. That's done. I'll stop the vacuum. Stop the vacuum first.
You waited about a minute.
Yeah. And then that's your pure compound.
Yep.
And I'm going to collect
really
it.
crystalline.
Yeah.
So you're getting a new, we call it a wing boat.
The wing boat, a new one.
A new wing boat, and it's tiered. Is it 0?
Yeah, I put that to 0. The balance has to be put to 0.
Yep, pretty close.
Yeah.
It says 50. Well, let's tear it again.
Good.
Tear. There we are, 0.00.
Okay, which is good. So you put your compound, you do like that.
Beautiful. And they have 0.12 grams.
Okay.
0.12 grams.
Yeah. So we did collect 0.12 gram of pure benzoic acid.
Pure benzoic. So the students will calculate the yield or something, or?
Yeah.
Okay, cool.
So as you see, we started with 380 milligram of impure benzoic acid.
380, right?
Yeah, 380.
There's 2 or 3? I think it's 3.
380.
380.
Yeah. And now we just have 120 milligram of pure benzoic acid.
120.
Yeah, milligram.
0.12 grams,
Yeah.
which is 120.
20 milligram, yeah.
Cool. Let's close this. Yeah. Cool.
So we cannot take the melting point of that today because it's still wet. If you take the melting point, you are going to have a deflation. To take the melting point, you need to have a completely dry compound, which is not the case yet.
So the water would be a contaminant.
Yes.
And it would decrease the melting point or deflate it a little bit.
Yes.
Got it.
Okay.
Okay.
So now this one is good for the solid waste. Follow me.
So you're going to dispose of it in the solid waste.
Disposing of solid waste. That's the container for solid waste. And what you do, you just dump all of that here. And you close it.
Hazardous waste.
Yeah.
Solid waste.
Yeah. Thank you, Dr. Anderson.
Okay.